Okay, we're going to look at the inverse functions homework. And what we're going to look at first, question number 1 here. We want to find out what f composed with g of x is and g composed with f of x is. Now, if they're inverses of each other, then they both are going to equal x. So let's see, we're going to look at f composed with g of x, which is f of g of x, which means we're going to take the g of x function and plug it in to f, all of the places where there is an input. So here's our g of x. This is going to go right in place of that little x. So that will look like 4 over that input minus 1. So I'm going to stick the input in here. It's x plus 4 over x. Now there's a few different ways that you could simplify this. I mostly, I normally look at trying to combine as many fractions as I can. So those two on the bottom, I want to combine those together. In order to do that, they need to have a common denominator. So we can rewrite the number 1 as x over x. So then that's going to get me 4 over, we'll have x plus 4 over x minus x over x. And so we can combine the numerators here, since they have the same denominator. And this will be 4 over, the x's will go away, so we're going to have 4 over x. But then anytime that you divide fractions, that's actually multiplying by the reciprocal. And so when we do that, the 4's will cancel out and we'll just be left with x. So we showed one direction. So now we show the other direction, g composed with f of x, which means we're going to look at plugging, not f, we're going to look at plugging the function f into g. So that would look like g of f of x. So we're going to look at f of x plugged into g. Well, our g function, we're going to go back up to the top. We're going to take this now and plug it in. There's 2 spots where it's going to be inputted. So we know the g function adds 4 to inputs and then divides by the input. So I'm going to put the inputs right here, which is 4 over x minus 1, and then this is 4 over x minus 1. So similar to the last problem, I try and combine my fractions, and so this is going to need an x minus 1 on the bottom. So we're going to write x minus 1 over x minus 1. So in the numerator, we're going to have 4 over x minus 1 plus that 4 will distribute. So we're going to get 4x minus 4 all over x minus 1. And this is all over 4 over x minus 1. So what we're going to have, combining these numerators together because they have the same denominators, the 4 here will cancel with this 4, so we're going to be left with 4x, and that's all over x minus 1. And then we have to divide by a fraction, so we're going to change that to times by the reciprocal. Now what's really nice here is that our x minus 1 and x minus 1 can cancel, the 4's can cancel as well, and so all we're left with is x. So it checks that way as well. So they both are inverses of each other. For this next problem, we're trying to find the inverse of this rational function. Now, because there's an x in 2 spots, it's a little harder to try and just use the words to try and write the inverse. So here we're going to actually do it algebraically by interchanging or replacing x with y. And so that will look like x is equal to y minus 4 over y plus 2. Now we have y in 2 places, but we still need to solve for it. So we want to try and put them all somehow on one side. But right away, I don't like the fractions in here, so I'm going to multiply by y plus 2 and y plus 2. So that way those will cancel out. So I'm all on one level now. So this will become x, y plus Okay, so as we distribute, we'll get xy plus 2x equals, on the other side we have y minus 4. So we have y's in two places and we're trying to solve for y, so we need to put them on the same side so we can kind of factor it out. So maybe let's keep some negative xy over here, so that way those cancel. We'll get 2x is equal to y minus xy plus, minus 4, and then we'll move the 4 over. So we have 2x plus 4 equals y minus xy. Again, we're trying to solve for y, so if we factor it out or undistribute, we're going to have 1 minus x there, 2x plus 4, divide by 1 minus x, divide y minus x. So that means that our inverse function, f inverse of x, will be equal to 2x plus 4 all over 1 minus x. If you had flip-flop stuff a little bit, you also might have instead negative 2x minus 4 over x minus 1. That would be okay too. Okay, moving on to number 3, we're again still trying to find the inverse. We could interchange x and y here, but since I see my x, I only have a single x there, it might be nice to try and go back to kind of using the words. So the way that function g is working here is that you're going to input something, that's where your x value is. You're going to minus a, then you're going to cube that quantity. Then you're going to divide by a, and then minus c. So again, if we think about what the function g inverse does, it has to undo all of that. So to undo minusing c, we're going to add a c. To divide by a, we're going to multiply or times by a. And then instead of cubing, we're going to cube root that quantity. And then instead of minusing a, we're going to add a back in. So that's what g inverse will do. So in math notation, that's g inverse of x will be equal to x plus c multiplied by, wait a minute, it wasn't divide by a, that was divide by b, sorry about that. So this will be multiplied by b. So we'll have a b here. And then we're going to cube root that whole entire quantity, and then we're going to add a at the end. So this would be g inverse. All right, we're going to graph this function, which is a linear function, and its inverse on the same coordinate plane. So again, we need to find the f inverse of x. We could do it in words, or we can do it by switching x and y. Maybe this one will do both ways. So switching x and y, we'll get x equals 2y minus 3. Add the 3 in, add the 3 in. We're looking at x plus 3 equals 2y, and then divide by 2. So it looks like our inverse function will be x plus 3 over 2. Or if we do the words like we did on the last question, we know that function f is going to be taking an input, timesing by 2, minusing 3, and so the inverse function, f inverse, will have to add the 3 in, divide by 2, and get us back. So what does that look like? F inverse of x will be x, you add the 3, and then divide everything by 2, which is exactly what we got over there. Now, if we're going to graph this thing, it might be a little bit nicer if we rewrite it as like y equals mx plus b form. So that means taking the 2 under both the x and the 3. So 1 over 2x plus 3 over 2. So there's like a 1 here. So we have this, we can identify our slope and y-intercept a little easier. So let's go back and we're going to graph our f of x function. So that has a y-intercept of negative 3, because you plug in a 0, you would be at negative 3. And then the slope is 2, so that's rise 2 spaces over 1. Or you could say it's a vertical stretch by 2, which would still, instead of going right 1 space up 1, it's right 1 space up 2. So this is our f of x function. Now our inverse function, we can just take these points that are nice and clear here and interchange them. So like 1, -1, right? This is 1, -1 would now have to be -1 up 1, which would put us here. This point down below, 0, -3, would be now -3, 0, since all our x and y's are interchanged. But then you can also see, looking at the actual equation for the inverse, that our y-intercept, right here, 3/2, which is 1.5, would be right here. And you can see that's exactly where our line was going to go through. So that kind of matches up nicely. So again, this is f inverse of x. And it should follow that they are reflections over the identity function or the line y equals x, which you can see they are. And that kind of answers question number 5, how you determine if your inverse function is correct just by looking at the graphs. And that's just, they need to reflect over the line y equals x, or the identity if you want to call it that. Okay, flipping over to question number 6, we're looking at a quadratic equation, which the quadratics are parabolas, and remember that they do not cross the horizontal line test, so their inverses wouldn't be functions. But if we restrict the domain, that means we're only looking at the right side of this guy, then it will be a 1-to-1. So let's graph this guy. It's a parabola shifted down 3 spaces. And it has that structure, right 1, up 1, but again we're not going to go to the left and up 1 because we only want it when our x values are greater than or equal to 0. So this is the function f that we're talking about. And so it says, is this function 1-to-1? And we say yes. And the reason why is because it passes the horizontal line test. Which means that every y value has exactly one x value. So it's like a function in reverse. So it says next it wants us to find and graph the f inverse on that same graph. So the inverse, let's interchange these values. So we already know that this is the point 1, -2, and then this is 0, -3. So if we're going to graph the inverse and not worry about the equation for a minute, we can just interchange these. So it wants -2 up 1, -2 up 1, and -3, 0. So there's our graph of f inverse. What does that look like? Ooh, the square root function, right? So if we think about the equation, based off of just the picture right there, that looks like our regular square root function, but it's shifted to the left 3 spaces, which would be written as x plus 3. And that is the correct inverse function. If you take a look back up here, the operations going on with our f function is it's squaring and then subtracting 3. So to undo that, we're going to add the 3 and then do the opposite, which is that square root. So next it wants us to talk about the domain and range of these functions. So the function f, we already know its domain is from 0 to infinity because it's been restricted to just that positive side. And the range is going to be -3, that's the lowest y value, to infinity. Now the inverse function, f inverse, its domain goes from -3 to infinity, and its range will be 0 to infinity. And what we hope that you're going to notice is that the domain and range just interchange. And the reason why it's doing that is because we're interchanging all our x and y's. That's the definition of the inverse. All the x and y interchange. And it's going back to, I already answered this question, but we wanted to restrict the domain in order to find the inverse function because otherwise it wouldn't be 1-to-1. just x squared as is not 1 to 1.